Example 4. On page 153 of verse 1, 3 fair coins are tossed. The number of heads, which is now the capital X, is counted for this experiment. A, write down the sample space. Before we go anywhere, we need to answer that question. We are told that three fair coins are tossed, and the number of heads, which is the main thing. Heads is the main thing. We have coin 1, coin 2, and coin 3. Is it possible for coin 1 to show a head? Yes. Is it possible for coin 2 to show a head? Yes. Is it possible for coin 3 to show a head? Yes. Is it possible for coin 1 to have a head, and a tail? We can also have a head, tail, tail. We can actually have that. Is it possible to have a head, tail, head? We can have all those outcomes. Is it possible to have a tail, head, tail, 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 head, tail, head, head, and tail, tail, tail? Let's see. Tail, head, tail, 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 head, tail, head, head, and tail, tail, tail. So we have 8 possible outcomes. We could have those 3 arrangements. That is part A. What about part B? What about part B? Part B is asking, write down the probability distribution. Write down the probability distribution. And remember, what you're having is we are featuring the appearance of heads. Appearance of head is the main thing. That's what we are terming capital X. So we are told to write down the probability distribution. And the probability distribution is just the number of heads. If you look at our sample space on the left, is it possible that we can have 0 heads? Yes. Is it possible that we can have 1 head? Yes. Is it possible that we can have 2 heads? We can have 2 heads. Yes. Is it possible that we can have 3 heads? Yes. It is possible that we can have 3 heads. So that is how we can fill up that top row. How many times can we register 0 heads? How many times? It's only this. Only when we have tail, tail, tail. This is only when we don't have any heads. Or rather, this is the only time out of 1, 2, 3, 4, 5, 6, 7, 8 times that we can have 0. So the probability of X is equals to X is 1 out of 8. How many times do we have 1 head? That is 1. And we can have another head there. 2 heads, 1 head. We can have 1 head if we have that arrangement. We can have 1 head if we have this arrangement, tail, head, tail. And we can have 1 head. We can have 1 head how many times? 3 out of 8. What about 2 heads? What about 2 heads? We can have 2 heads. Those are 2 heads. Yes, those are 2 heads. Those are 2 heads, so 2. And these are 2 heads, 3. How many times? 3 out of 8. Is it possible to have 3 heads? Yes, only that time. So 1 out of 8. And that is how we can simply answer part B of the question. And this table is giving us a lot of information. It is very critical that we understand this table, because we are going to say if you add all these, the sum of the probability will give you a 1. But before, let's keep that awaiting, we are going to see the summation of the whole of this row should give us a 1 there. But part C of the question, write down the probability functions. Write down the probability function. What is this we are expected? The probability function is we should now parade all the probabilities. The probability function, when x is equals to small x, we have all of them, yes. Yes, we have 1 over 8. Yes, we have 3 out of 8. And we may have another one which could be 0. When do we have 1 over 8? We have 1 over 8 at that particular point and that particular point. When we have 1 over 8, only when we have the value of heads, the number of heads to be 0, and the number of heads can also be 3. When the heads are 0, then the probability is 1 over 8. When the heads are 3, then the probability is 1 over 8 again. When do we have 3 over 8? When do we have? We only have the probability 3 over 8 when we have the number of heads, 1 head or 2 heads. That is only when we have a number of, we have the probability 3 over 8, only when we have 1 head or 2 heads, according to the table. And this is what now we are calling the probability function. It is true that you may include the probability of 0, which should always be there, and you should always have an otherwise, because we are not limited to only what is appearing. Sometimes we may have an otherwise, and that otherwise should always be taken care of. Having said that, we can also say this is a way of writing the probability functions when the probabilities are not all the same. When the probabilities are not all the same, then we can come up with our probability function. And that is just like it for example 4. Thank you.